indeterminate forms and limits that have indeterminate forms. We're going to be using L'Hopital's rule to work these out. Now, an indeterminate form is basically what happens when you're trying to take a limit and you end up getting a 0 over a 0, or a 0 times infinity, or 0 raised to the power of 0, or infinity raised to the power of 0, or 1 to the infinity, or infinity divided by infinity, or infinity minus infinity. Those are all different indeterminate forms. Now, going back to our basic trig limit that we had from the very beginning of our course, we know that this limit is 1. However, if you just go ahead and plug in your 0 for your sine and your 0 for your x, you get 0 over 0, which is an indeterminate form, means you cannot determine what the answer is till you do more work. And in this case, through more work we did before, we ended up getting 1. Now, L'Hopital's rule basically says if you're trying to take a limit of a fraction, and it has to be a fraction or quotient, and you end up getting 0 over 0, then all you have to do is take the derivative of the top and the derivative of the bottom, and then try it again. Now, we are not using the quotient rule here. L'Hopital's rule says just derivative of the top, derivative of the bottom, not a quotient. Well, L'Hopital's rule also has some corollaries that allow it to work then with not just 0, but with infinities. So if you had like infinity over infinity and so on. That's what L'Hopital's rule says. But before you use L'Hopital's rule, you need to make sure you're dealing with a limit, you need to make sure you're dealing with a fraction, and you need to make sure it's an indeterminate form. So as we look on this problem here, if you plug in 0, you get a 1 minus a 1, which you know is 0. Plug in 0 on the bottom, you get the sine of 0, which you know is 0. So you get 0 over 0. So yes, it's an indeterminate form. So we're going to apply L'Hopital's rule that says take the derivative of the top. Your derivative of your e to the x is e to the x. Your derivative of your 1 is 0. Then you got to do the derivative of the bottom. Derivative of sine is cosine of your angle, but then got to multiply it by the derivative of the inside, which is a 2. Now, L'Hopital's rule says after you take the derivative of the top and bottom, now try plugging in your 0. So you plug your 0 on the top, you get 1. Plug your 0 on the bottom, 2 times 0 is 0, cosine of 0 is 1, times your 2 is 2. So you end up getting an answer of 1/2. Same idea over here. We're going to plug in our 1. We'd have 1 minus 1, which you know is 0. Natural log of 1, which means e to what power is 1, that is 0. So you get 0 plus 0, which is 0. Plug in 1 here, you get this cosine of pi, which you know is negative 1 plus your 1 is 0. So you get 0 over 0 once again, which is an indeterminate form. So you take the derivative of the top and the derivative of the bottom. Notice your normal 1s here when you take your derivatives will drop out. Derivative of your negative x, derivative of your natural log, derivative of your cosine, you know, is negative sine, but you also have a pi hanging around in front because you're dealing with the derivative of the inside, which is pi. So now you could try plugging in your 1. So you get a 1 here plus your negative 1, which is 0. Plug in your 1 here, you get 0. 0 times your negative pi is 0, so you get an indeterminate form again. Well, L'Hopital's rule basically says if you get an indeterminate form a second time or a third time, just keep doing it. So we're going to do the derivative of the top. Derivative of this is 0. This is an x to the negative 1. When you do a derivative of x to the negative 1, we get this. Derivative of the bottom, your only variable is x. Derivative of sine is cosine, so you're going to have your negative pi hanging around. Cosine of this, but then you got to multiply it by the derivative of the inside, which is an additional pi, so you get a pi squared there. Well, that ends up simplifying a little bit. You can put your x squared on the bottom, because technically you're multiplying the top by an x squared, multiplying the bottom by an x squared. So on top you get your 1, because the negative on the top undoes the negative on the bottom. We now go ahead and plug in our 1. 1 squared is 1. Pi squared, plug in our 1 here, cosine of pi is negative 1. So we get a negative 1 here times your pi squared on the bottom. So we do get a limit of 1 over negative pi squared. Well, we need to go ahead and try to take our limit. So we plug in 0, 0, and 0, and we get 0 over 0, which is an indeterminate form. So you take the derivative of the top, derivative of the bottom. Then you try to plug in 0. Plug in 0 on the top, cosine of 0 is 1. Plug in 0 on the bottom, you get 1, so you get 1 over 1 or 1. Same idea over here, but now we're dealing with infinities. 2 times something really big is something really big. Natural log of something really big is really big over something really big. So infinity over an infinity is an indeterminate form. It's a quotient here, so we can use L'Hopital's rule. So we take the derivative of the top over the derivative of the bottom. You'll notice the 2's drop, so you just get an x, 1 over x, all over 1, don't need it over 1, so it's just a 1 over x. Now you try putting in infinity. 1 over something extremely big, you know, is 0. Once again, we're looking at infinity here. E to a really big power is really big. Natural log of something is really big, so it's infinity over infinity. It's a quotient, so we can use L'Hopital's rule, derivative of the top over the derivative of the bottom. Instead of dividing by a fraction, you multiply by the reciprocal, so you get a 1 times, or not a 1, an x times your e to the x. Now we try putting in something really, really big. E to the x is really big, times something really big. Infinity times infinity is infinity, so you get a limit of infinity. Once again over here, we'll put in our infinity. Infinity squared is infinity. E to the infinity is an infinity, so you get infinity over infinity, which is an indeterminate form. It's a quotient, so we can use L'Hopital's rule, derivative of the top, derivative of the bottom. Now you try plugging in something really big, so you get infinity then over infinity again, in indeterminate form, so you do it a second time, derivative of the top, derivative of the bottom. So now you plug in infinity, you get 2 over something really, really big. 2 over something really big is 0. So we're going to go ahead and continue to do that here. Plug in infinity, square root of infinity, indeterminate form, take the derivative of the top, derivative of the bottom. Fraction divided by a fraction will simplify a little bit. Multiply by the reciprocal of the bottom. So you get a 2 on the top over a root x. Because remember, this is x to the half, this is x to the first. You have an x to the 1/2 on the bottom. So now we go ahead and we plug in our infinity. So we get 2 over the square root of infinity, which is infinity. 2 over infinity is 0. Over here, we go ahead and try to plug in 0. Plug in 0. Derivative of the top, derivative of the bottom. Then you plug in your 0. E to the 0, which you know is 1. Plug in 0 on the bottom. You get the cosine of 0, which is 1 times 2, so you get 1 over 2.